bit. I'm hoping to show you guys some ways to um, package up examples in a potentially slightly more example or publishable way. There's kind of a stack of abstractions um, that build as you are working in different domains. So typically, we've been working in developer domains. We're working on our local box. We do local bind mounts with Docker. And then you consider the next level. You want examples, and then you want external user examples. And then maybe the next layer in that stack is somebody who actually wants to use this in production. So they do a production test, and then after that, then you've got actual production deployment. So all those different layers in the stack add extra abstractions, and you kind of have to package your stuff appropriate for all those different levels. So I'm hoping that we can start moving from, the local development workflow to that next layer in the stack where we're able to hand off examples to other developers, and it's real easy for them to run. And, again, eventually later we'll be able to package up examples in a different way for, light production use cases, and then eventually, way down the line, production use cases. So let's start with a problem that we might want to have. Let's work with some addresses. Let's work with some physical real world locations and do some interesting stuff with that. Let me share my screen here. And this is my first time using VS Code in the browser, actually served up locally here. So there may be some bugs. But I'm assuming you guys can see this. Is this correct? So here's our code studio. Let's say we want to work with these addresses, just a couple random addresses from places I've lived or been to. And typically what we've done so far, for examples, is we'll use new table and string column and create this table, right? So I'll go ahead and run the selected, and you've got your inputs here over as a table. So the first thing we might want to do when we're progressing beyond the local development workflow is to package this data up in a usable form besides just code here. So let's say we want to do a CSV file. So here's the CSV file. I'm calling this just my directory structure. Here's the date, and then the different examples we're going to go through here. So this first part of the example, oops, we've got a CSV file. And what I'm going to show here is one way to extend the images that we publish in a declarative way. So we publish our Docker images. And so one way to get this CSV file packaged up into another image is to use what is called the copy command. So here's a Docker file, and a Docker file are the instructions to build a new Docker image. So what I'm doing here is I'm extending our officially published image from Google Hub Container Registry. You'll notice I'm using the tag edge here, and that just means it's from every commit domain gets published there. And so this is not our latest release, it's our latest main. And I just want to go ahead and copy inputs into the current directory in the image. So what I can do for this is I can do, I'm kind of in a weird environment here, so I have to do a sudo, but I could call this my new image, and I could build it like that. So what it does is it's extending from our previous image, and it would pull it down if I didn't have it locally already. It's copying the inputs and is creating a new tagged image. So we'll see I have a new image here. I actually did this 7 minutes ago, but it re-tagged it as my new image here. And this is something we can use in place of gRPC API in our Docker Compose now. So here's our Docker Compose, and all this is basically copy paste from other places. The only new interesting part of this whole Docker Compose is instead of referencing our gRPC API image, I'm going to reference this. I actually did a build script here that does the same thing. It just gives it a slightly different name. I'm going to go ahead and run that build script. So it's going to go ahead and create this image for me. I'm giving it example1 data tag and this name and this namespace, and then our Docker Compose file. I'm referencing that new image. So now what I can do is I can go ahead and bring this Docker Compose up. And actually, we're already up and running with that. That's what you're seeing over here. And so now we should have a file that we can get access to. Let me go ahead and grab some code over here. I'm going to go ahead and import CSV. And if all this works well, I should be able to go inputs is equal to read CSV inputs.csv. So there we go. So now inputs.csv is officially part of our image. We can publish that image, give it to somebody else. They don't need to worry about volumes. They don't need to worry about local mounts. They need to worry about any of that. And so that's example one. It's adding data that you want into the image. And again, we're extending the official gRPC API edge image and adding our own custom data.
So before we leave example one, are there any questions, since we're mixing Docker Compose and Docker and we're copying data in?
Is this our official expected way to have customers basically inject their own dependencies to our Docker file?
I mean, this isn't injecting dependencies into our Docker file. This is
our Docker I guess file. Extending it.
I mean, this is the official way to extend Docker files.
Gotcha.
I am going to claim it is a pretty good experience for extending, for example, use cases, and maybe even all the way up into production use cases. But we're not that far yet.
Okay.
And so right now, this is kind of the easiest way, in my opinion, to kind of add small amounts of data into an image and potentially publish it yourself somewhere else.
Sounds good. Sounds good to me.
We also mount a local directory under /data, and that's another way to get stuff there without having to bake it into an image.
Sure. And we've got some examples where we pull stuff down. This is more of a packaging exercise as opposed to pulling data down. And just so it's even a little bit more clear, the Docker file makes new images and the Docker Compose just starts existing images, at least in this case.
So is your CSV file actually in the data directory now because it's in the image, or does it just live in the image?
It's actually lives in the image. It's not in the data directory. We can, if we actually want to.
Yeah, so I think this Docker file puts it under in the root directory.
Yep. So what we'll be able to do here is we'll just be able to inspect the image right here. We'll be able to see that I'm jumping into this container right here. I'm listing out the contents, and our inputs.csv is right here. And if we look at our current directory in the image, it's going to be /app inputs.csv. So it's not in data at all. It's baked into the image. So now let's go ahead. So we've seen how we can add data, extend our own data into the image. Let's go ahead and extend some code. Okay. So let's go to the next Docker file. And this is going to get into application mode. So application mode is a way where you can pre-package some sort of logic that always runs on startup. So if we always want to load the that CSV file on startup, we could do that with application mode. So here's another Docker file. We're going to create another image. You'll notice I am not extending from the Deephaven image. I'm extending from the image in example 1. So this image, again, already has our inputs.csv in it, and now we're going to add some logic into it. So I am copying the application, the app.d directory locally into the containers or into the image app.d directory. The application, so application, again, is something that starts automatically on startup. Basically, it looks for any files .end and .app, and that's the specification for it. So right now, I don't want to go over necessarily all of these different configuration options, but basically we're telling it's a script. It's a Python script. We have an ID. We have a name. It's enabled, and then we tell it the actual script we want to run. And so this value right here is pointing to this file right here. And this file right here is just a collection of the methods that you saw me run previously, creating a new table manually or reading the CSV. And so the idea is if we run this file on startup, then the user is going to have access to these functions, get inputs manual and get inputs. The one other thing that we have to do when we're starting up, so it's exactly the same Docker compose as before, but we just have, except we're referencing this new image and we're referencing the application directory. So what we're going to go ahead and do here is we're going to go ahead and go to the second application example. We're going to go ahead and build it. And again, building it here is building that Docker file and tagging it appropriately. So I'm going to go ahead and do that. Went ahead and built. And then we're going to go ahead and start it up. And I've gone ahead and chosen different ports to be exposed. Yeah, that's the only other different thing is I'm exposing a different port for every example just so I can have them up all at the same time without port conflicts. So this is, so we go ahead and starting up. If we go ahead and go over to port 44 now, we'll have another server running. And if we go ahead and see if get inputs works, hey, get inputs works. And get inputs manual works. And we know under the covers again what these two functions are doing. Get inputs manual is running this code right here, and getting inputs is running this code. So if you want to potentially package up some more complex operations here and expose them to the users in easy form, it's really easy to go ahead and do that with something like this. Now, let's say we actually wanted to preload the tables. So we could go ahead and do that. Let's go ahead and do this live here. So we can say inputs manual is equal to get inputs manual. Okay. And inputs is equal to get inputs. And so again, this is changing our script here. We'll go ahead and rebuild it. Let me go over here. Let me go ahead and go ahead and get rid of this layout that we have here. Go ahead and rebuild it. So we have a change to our image because I added these tables as part of the startup script. There we go. We go ahead and refresh this. And let's try again. And boom, now we've got our tables already in the global scope right here. Inputs have already been created and inputs manual have already been created. So it's not just providing functions to the user. Now it's actually providing tables on startup. And if you wanted to look at the Docker logs here, just to see what it looks like, pose logs, gRPC API, you'll be able to see at startup that, actually my scrolling isn't working here. It looks really bad because I'm in a browser with a lot of stuff here, but you'll see it found my startup script and it ran it at startup. So again, we're extending from the first example. We're adding some application logic. Our application file is pointing to the script we want to run, and the script we're running is adding some functions and some tables automatically.
Okay. Any questions on 2 before we move on?
This is kind of just an aside question. Is there a reason you're doing everything as sudo? Is that required for doing this, or?
It depends how your environment is set up. I'm running Docker and Docker here in the browser, and I couldn't get it to work without sudo.
Okay.
So your local setup may work without sudo, but in this particular environment I'm in, Docker needs sudo to run. And typically Docker does need sudo, but usually you add yourself to the Docker group. But I wasn't able to do that in this case and didn't have enough time to figure it out.
So, for example, in Linux, if you do a fresh Docker install, it's going to ask you to do sudo until you add yourself to that group.
Did not know that.
So,
is there an easy way to wrap up an image and just share the image that has the information with people?
Yes,
rather than...
that is what we're going to get to in example 5 release. But yeah, you can publish these images, and then they don't have to worry about building it at all. So we're working up to that, but we want to do some more interesting things first. Are you ready to move on? Okay, so now we've got some data and we've got some ways to script up some stuff. Let's go ahead and add an external library, and we'll see what we're going to do here. So let's look at our Docker file again. So we're going to extend an image again. I'm not extending the second image. I'm extending the first image again because I want to make a slightly different application. But what we're going to do now is we're going to install a Python library called GeoPy. So this is a geocoding library that could reach out to Google Maps or OpenStreetMaps or different geolocation providers, so we can do some interesting functions on those addresses that we saw earlier. And then we install the library, and then we're going to create the application again. Just as before, we've got a simple Docker build command here to build it. I'm going to go ahead and build it. You'll go ahead and see it's going out and fetching GeoPy and installing it. And then we've got it right here. And then the Docker compose file is almost exactly as it was before. I am running on a different port. I have a new image referenced here, but otherwise it's exactly the same. And if we look at our application, it looks almost exactly the same as before, but our script has changed here. So let's walk through this stuff a little bit. It might be a lot to dump here at first, but we are importing GeoPy, and we want to figure out what the name of the address is, like what the business associated with the address is. Nomatin here is, I believe, the OpenStreetMap publicly available geo coding service, and then we might want to also look at the distances between different locations. So to geocode the input, we're going to call the geolocator. We're going to get the address name. We're going to get the latitude and longitude. Here's how I get the distance in miles. And here's how I hook it up to Deephaven. So I'm going to go ahead and do an update call. So we're going to take our address as input, and we're going to geocode it, and then we're going to get out the name, the latitude, and the longitude, and then we get rid of the temporary object. So let's go ahead and run this, and we'll Docker close -d. I incremented the port by 1. So I don't have any tables here predefined, I don't believe, but we can get inputs just as we did before. So here's our CSV inputs. Now let's go ahead and add geographic information to it. And here's where I cross my fingers and hope that the external APIs are working. Let's make sure boom, there we go. So now we've got the name, latitude, and longitude of these addresses. You can see these are very important places: In-N-Out, Dutch Bros, Dick's Drive-In, Starbucks, Mall of American Garden of the Gods, with their corresponding latitudes and longitudes. And let's say we wanted to figure out what the distance between all these places was. I created a distance matrix function right here. And so we're just joining the locations with itself, making sure that we're not doubling up. So we've got this condition right here, calling the distance function, and then viewing the results. And so what we can go ahead is get our distances with our info. And there we go. So there are all the locations cross-joined with each other and the distances in between them. So what we'll probably want to do is here sort what are the 2 closest locations. So these are both locations in Seattle: Dick's Drive-In and Starbucks. And then the farthest locations are Mall of America, which is Cleary, Minnesota, and the Home Depot, my local Home Depot here in Oregon. So yeah, so that's how you can bring in a interesting third-party library, do some actually interesting stuff with it, and bring it all into Deephaven. This wasn't meant to be so much a demonstration of cool geocoding libraries, but how you can integrate a third-party library in Deephaven and do interesting stuff with it. So let's just as we did before, let's go ahead and canonicalize these as pre-built tables. I don't know why it's not letting me paste. Let me see if it looks like my paste is missing. So I'll just go ahead and do it here again. So we'll do git inputs. What do I have? Inputs with info. Add geoinfo to inputs. And then what is what I call the last one? Distances. Distance matrix of inputs with info. We'll go ahead and save that. Then we'll build it. Oops. So now we've updated our script. We will bring up the image again. And now when we restart this, we should have let's make sure everything's working here. So this is port 45. I'm on the right port. There we go. So now we have those things automatically pre-populated, so we can go back to our distances and can see that, yes, server has automatically started that on startup. Any questions about this example?
I'll just make one note. So you've got .call in your update. That shouldn't be necessary anymore.
Sure. Yeah, so it's let's find out. So you're saying just like that?
Correct.
Yeah. We will find out.
Now I have my fingers crossed.
And we'll restart it. So, I mean, that's a good example of hopefully how fast it is to be able to do editor development, but still, produce interesting packages and in a reusable form. So let's hope that Docker or the networking. I've been having issues with Docker taking a while to
Would these
restart the
Docker
networking.
issues go away if we did a Docker down in between every Docker compose, or is it okay to do multiple Docker composes?
This should restart it. Technically, it should be fine. I am not a Docker networking expert, but hey, there we go. Look at that. So yeah, great call on the getting rid of the call, and here's our results again.
I have to hop off, but I just wanted to say that this is super cool and very informative. Thank you.
So again, what we did here was we extended our own image. We could, which extends the Deephaven image. So this has our inputs.csv in it. We installed a third-party library. Could be any third-party library we wanted through here. And then we went ahead and packaged up some logic around that in our application directory. And now we've got this right here. Our next example is going to be taking it a step further. You noticed on this example right here, we had to go up into the panel and click our inputs to bring them on the screen. What we're going to do here is we're going to take all of this and we're going to also package a layout. And so a layout is how the web knows how things look. So let's go ahead and actually we'll base it off of our example 3 first, because I actually haven't done this yet. So here's part of the demo that I actually haven't done yet, and we'll hope it works. Let's go ahead and sort distance by ascending. So shortest distance first. We'll change the rename of this as, we'll just call it distance matrix, just to give it a pretty name. We'll go ahead and give our inputs here. Rename these are, we'll just call it inputs.csv, and we'll take another inputs with info. We'll just call this decorated info, just to give it a nice little name. We'll drag and drop these next to each other. All right, so that's kind of the order that we went in, at least logically. And just for fun, let's give a markdown widget here, right here. It says, welcome to the, what was I calling this application? Doesn't need to be this name, but let's just copy it for consistency purposes. Welcome to So we could have a note. Let's say we wanted to have this note at the top of our screen, and this is the layout we wanted. So what we want is when somebody runs our application, they come to this screen automatically without having to do any of the panel stuff themselves. So what we can do is we can go ahead up here to panels, and we can go export layout. I don't think you're going to see this screen, but I've got a save dialog here, and I'm going to go ahead and save the file locally. And then we're going to jump back to this application right here. So for layouts, it's almost exactly, it's going to be a very similar concept, but instead of extending our server image, we're going to be extending our web image. And what I'm going to be doing here is copying from this layouts directory right here, which is currently empty because I haven't copied the layouts over, and we are going to be copying it into data layouts. And so that's where the web expects to look for its layouts. Give me 1 second here as I copy the file I just downloaded.
So layouts will store the table information as well.
Yes.
What do you mean exactly?
Well, we're not importing the CSV data or the scripts for the library that we use, the geo library.
Well, I think that the server is doing that still. Devin can specify, but I think that on the web side, it's just saving where the components are and how they're configured.
Yeah, so this is if you packaged it and gave it to somebody else, the layout would automatically show up. And this is something, so CP. Okay, I've copied it. So here's the layout. And actually I can make it pretty real quick. GQ. Sorry about this part of it. So I've got a layout here. This is, did I do something bad? No. So here's the layout. So this is the layout we just built earlier in example 3 that I exported, and I just moved it to this directory. I don't know exactly what this format is. It's a JSON stuff that basically says what everything is and where it's located. Binder would have more information on this, but for now we're just stuffing it in this directory, and we're giving it some instructions to add it to this directory. So let me go to example 4. Just like before, we're going to do a build here. And again, this is extending from the web image, not the server image. And so we have one more part that we need to change in our compose file. So this is exactly the same as it was before. The only new thing here is now we're referencing this new image on the web side of things that has the layout we want.
Yeah. So Amanda, if you look in the gRPC API section, you can see that that's where the actual data is coming from.
Yeah, I see that.
And so let's go ahead and pose up-d. And I am choosing one more port, I believe, 46. So we'll go ahead and we'll see if this actually works. Sometimes there's a browser cache issue that causes this not to automatically reload since I've already visited this port before, but we'll see. We'll see what happens. So, yep, this is a separate, this is a different application. Let me go ahead and reset the layout here. And there we go. So that's the hope, is that when a new user opens this up for the first time, they're going to jump directly into this layout. The reason why it wasn't when we just loaded it is because I had a browser cache issue because I'd used this port for something else before.
Okay, and how did you reset that? You went to panels,
and then there's this reset button right here. So now it is pulling from the layouts directory. I've told this to Bender, and I think there's a fix that will eventually come. So it'll be smarter about not caching it when there's stuff there. So yeah, so there's our layout that we built before. This column is still sorted. And we've got our decorated info and stuff like that. So yeah, so if somebody else wanted to make some changes here, and then if you wanted to re-export that, you could just go export layout here. So now we've got, kind of a full application here. We've got let's go back to example 3. We've got our data that we've added. In the first case, we've got some new libraries. We've got application scripts, and we've got layouts now. And that is what's produced at the end of the day. Any questions about that layout example? All right, now comes the fun part. Releasing. So let's say we're happy with this, okay? And we want other people to be able to use it. So what we can do is we can tag our images. So I want to tag this image that I built locally. I'm going to give it a new name, just a more descriptive name for when I publish it, as opposed to, example 3 or example 4. I'm going to call this gRPC API Geo and WebGeo. Okay. Nobody else will be able to run this because it is on my personal GitHub container registry, but it would be easy to modify this for your own GitHub usernames.
Can you talk a little bit about that? Is that configured by default for everyone, or do we need to do something?
I don't remember. You may have to, if you're already authenticated with GitHub locally through Docker, it may you just may be able to push to your own namespace already. There may be some other setup stuff in GitHub. I don't remember exactly what I went through to get this, but I'd be happy if anybody was interested to walk through that later. So here's the image that we built in example 3. Here's the example that we built in example 4. And again, we're just giving it a better name and specifying the GitHub Container Registry repository. So I can't actually run this in this container because this container isn't privileged. I have to run this on my local machine. So you won't see me running it right now. But I am going to be running publish here. And I've gone ahead and published it. So you'll be able to see that I have just tagged these a little bit ago. And I've gone ahead and just pushed them. And now we have what I'd call a release Docker compose file. I am referencing this latest Geo one that I published, and this web one that I've published, and then the official ones or some official ones for Deephaven. So anybody, I should be able to hand this file off to anybody, and they should be able to start it up themselves. So what that would look like is just running one more time. We'll go up -D. And it'll look like that. It would do polling for you if you haven't already pulled it. We'll go to port 47 here.
So Docker Compose up will do a pull for you?
I believe so. Looks like we are having more layout issues because I've already been here. So I'd say, why don't, if any of you are interested in giving this a try right now, this should work for you. I will paste this file. Actually, is copying working? No. I've actually published this code though. DevRel, sorry. I'll paste this in the channel. Slack, what channel should I paste it to? Any preference for what channel, or should I just do it? I'll just do it to the, yeah. So here's a link to the compose file. If you go ahead and download this to a new directory and then run Docker compose up, it should go ahead and do exactly the same example. Does anybody want to do this live and present and see how it turns out? Any takers? Jianfeng?
Sure, let me do it.
Yeah. All right. Let me stop sharing here.
I'm gonna
I can
share
walk
my
you.
screen. Let's see if it works. Which one? This is the one. Share. Well, all right. So I have
Yep.
this guy here.
Yep. Just create a new directory and then create a Docker
Yeah.
compose.yaml file and paste those contents into it.
Yeah. So go into my temp, doc compose, doc YAML, right?
Yep.
Uh,
Perfect.
okay. Cool. Those, right?
Docker dash compose typically.
I think mine is fine. Yeah. Oh, so it's not automatically.
I think this is an authorization issue.
I got the same one.
Yeah.
Got it. Oh, I need to make it public. That is a good reason we do
It's a
demos.
good test, man.
Give me 1 second here, and I will go make those public for everybody else. Packages.
So do you tag each image as being public, or do you have to do something else?
I think it's just the name of it. So gRPC API Geo, I need to make it public once. Change visibility, public. gRPC API Geo, and I have to do one more image. Give me 1 more second here.
Oh, the web one, right? Mm-hmm.
Yep, web geo. All right, can you try again, Jianfeng?
Sure. Ah, look at that.
And if you already have the Deephaven Edge image downloaded, the download would be really small. But I think you're downloading all of the latest release, or not the latest release, the latest main.
So this is 47.
Yeah, let's go see if it's done downloading.
Oh,
Because I think
still wow.
Yeah, it's our image is a little bit big. That's okay.
So it's creating. So for all the intermediary images, I actually can use the local build, right?
You could, yeah. So that's the other thing. If you're developing locally, instead of referencing the edge builds, you could reference a local build tag, and you'd not have to download anything. Yep. So 47. Hopefully you haven't had anything running there before. Let's see if the application. Hey, look at that.
Wow.
I guess the only difference is it didn't pop up to the note tab, but the note tab still is there. It's there. Yeah. So
yeah. Okay.
Perfect. It was almost good, except the note didn't show up on
right
as highlighted, and I'm not sure.
Super cool. Super cool.
There you go. So that is how you publish. You can publish and release a kind of full Deephaven example application, and then somebody can get up and running with it with essentially one command.
Yeah, I guess from our side, we have the example repo with example data. There may be some circumstances where we want to publish images under that project. So just something to think about.
Yep.
Who's the owner of our GitHub container repository to add containers to it?
Me and Chip and Ryan and maybe Bender.
And while I may be an owner, that doesn't mean I know how to do it right now.
Yeah. So I think that's all. I think we're running over time here. I don't know how typically long these go. Happy to stay around and answer any questions you guys might have.
Yeah.
Oh, I know what I was going to do. So I was going to take it to the next level here. And show you. So I'm hoping everybody understands the concepts a little bit more of extending images. Again, extending the server image with data, extending the server image with libraries and application logic, extending the web image with a layout, and how releases, you can release your own images and pull them down with the simple one example. I have done this with a Java project that is a bit more involved, and we can walk through this just a little bit right here. So this is a demo I gave a couple weeks ago. Ran very similar concepts where I was pulling in some crypto data, publishing to Kafka, reading from Kafka, all in a single deployable app, kind of like I've demonstrated here. There is a lot more structure to it, though, because there's a lot more code behind it, a lot more Java code. But just to give you a flavor of what it looks like, is we've got our Gradle project here. We've got some third-party stuff that we're pulling in. If we look at our build Gradle, so we're relying on some third-party stuff right here. We've got code behind this too that I've written. What we're doing here is we're creating a Kafka publisher. So this is a standalone application that publishes to Kafka. And then we have a Kafka consumer. And this will look very familiar, right? We're extending our server. Instead of pip installing stuff, we're adding extra jars to the class path, and we're adding an application directory. So it's a very similar feeling flow. There is a lot more structure behind it because there's a lot more class path stuff that's going on right here. And there's code behind it. And then there's slightly more complicated examples that I have behind here. But you can do the same sort of thing with more complex examples. So I'd say what I went through with the Python stuff was, a very a pretty light example, and this would be more of a trying to bootstrap up a more complex application that is one tier above an example, I'd say. So, and if we look at the Docker Compose for this, so this is a standalone service. So this is a completely new service that publishes data. So it's not the gRPC server. It's not the web server. It's a new process that is publishing data into a Kafka, into Red Panda. We also have a custom server, again, that does have the application logic attached to it. And then again, a custom web that has the layouts attached to it. And then that Kafka image right here, but then the gRPC proxy and Envoy as stock. And so this is where I'm starting to layer some more pieces onto the puzzle, and starting to do some other stuff. But the end deliverable is still a single Docker Compose file that you can publish, that I have published. Let's Jianfeng, do you wanna be a guinea pig one more time?
Why not? Yeah.
Perfect. So I'll stop sharing my screen here.
Give me the link.
Let me go to it 1 second. I believe I've made these public. Stop presenting. I've sent you a Slack link, Shanfeng, if you want to
Oh, okay.
get that
Sure.
and share your screen. And yeah, just replace the existing Docker compose file or a new directory or something.
Yeah. I'll just replace the existing one. Oh, let me share my screen first. All right. Oh, what the? What did I do?
I don't know.
I copied. Oh, stupid me.
You could just curl it.
Oh, something's.
All I saw there was a woman in a red dress.
What?
You know, I'm
It's from the
excited
Matrix.
for the new Matrix. Have you seen
Yeah.
the trailer?
I have.
Yeah.
I am excited and concerned all at the same time.
Yeah.
Sorry. I'll just do
Probability of
this.
success for that one is not high.
Delete it.
Yeah. Okay, let me just make sure I copied it correctly. This is the one, right?
Yep.
Second one.
Probably gonna have to do a little bit more downloading because it's probably not based off of the same images. But
Oh, yeah.
that's fine.
fine.
We'll,
Yeah. Okay. Yeah. So I'm gonna come here. What's the port number on that one? Let me check.
it should be port 42, 10,042.
Envoy. Where is Envoy?
Right there at the
Oh,
bottom.
42? Okay. Yeah. I think in this example, what scares me is the Gradle part. That is.
Yeah, and that's I was thinking about doing the whole demonstration today in Gradle. I'm like, it's going to be a lot easier just to keep it as a simple Python buildable example. But the Gradle is really nice when you actually want to work with Java libraries or write Java code.
Okay.
So it kind of depends what kind of application and what kind of library support you need.
Nice.
Hey,
Cool.
so there we go. So he ran one command kind of, and he's got some real crypto data flowing from half a dozen exchanges, a couple different names. It's got some interesting aggregations going on. And yeah, so that
Looks
is.
like a charm.
Yeah.
Nice.
So it looked like you had one more example with volumes.
I was going to talk about Docker volumes a little bit. It was kind of a little bit different than the rest of the stuff. I don't think it's really that important, but I'm happy to talk.
You want to do that on Tuesday?
What's Tuesday?
We could do it now, or we could do it when we meet on Tuesday.
I guess we talk about it now. I just wanted to motivate a little bit. Jean-Vin, can you stop presenting? Thank you. That was very cool that it worked first try there too. So as you can see, that was a much more complex application, was doing more things, had a lot of Java code behind it, had some Java jars behind it. The Gradle build logic behind it is more complex than the build scripts that we saw in examples 1 through 5. But it kind of depends what domain you're working in. But at the end of the day, we are still able to deliver kind of a single endpoint for consumption of that application. jumping to a slightly different topic, I want to hopefully educate about Docker volumes a little bit more and advocate for preferring explicit volume naming. And it's particularly important when you are releasing this image to external people, as opposed to necessarily advocating for bind mounts. And let me go ahead and share my screen again. So I didn't spend too much time working out this example. I have just a red panda image here that it has a volume that it likes to create, that it creates, because this is where it stores its database, varlib red panda data. But let's say that we didn't explicitly mount the volume, and we didn't declare the volume. So let me actually go ahead and tear down all of my previous examples. One thing to note is when you do it down with the -v, that will delete all the volumes associated with that. Sorry, I gotta do sudo. Gotta clean up after myself here. 1 second. So some of you may have run into this before, where you may run out of space locally and you notice that Docker is using up a lot of that space. And what I want to advocate for is practices that will hopefully alleviate running into that situation with some Docker best practices.
You recommend doing downs rather than the kill alls and deleting and pruning, or?
It depends what you're trying to do. So that's depends. So let's start here with listing our volumes. We shouldn't have any. Did my screen just go away, or have I not been presenting?
You were presenting, we lost it.
Don't know why that went away. Okay, so I've got no volumes here. And let's say I bring up this Docker compose file. Compose up. Okay, I bring it up. Oops, I meant to do it with -d, but that's fine. Let's say, oops, I meant to bring it up with -d. I'm going to go ahead and cancel it. Now I'm going to bring it up. Maybe I want to kill the container, and then maybe I want to bring it up again. Okay, with the -d. Oh, great. Okay, so I actually have 2 volumes now, because the red panda image implicitly creates an anonymous volume whenever you don't specify it explicitly. So if we do a Docker volume ls, we have 2 volumes now. And if we don't clean up that volume, it will be there potentially for a very long time. You know, these volume names aren't very descriptive. You can inspect them. You can Docker volume inspect. I don't think copy and paste is working in this environment. Maybe it is. See if that works. No, we could inspect it and get to where its location is, but we've got 2 volumes here. So if you are using an anonymous volumes and you do a down without a -v, it leaves garbage behind. Now, the reason why it does this is it doesn't want to delete data that you might actually want. So if you create a system in a production environment and you accidentally kill all your containers or bring all of them down, it doesn't delete the data out from under you. So you could go ahead and recover this anonymously named volume and from your file system. But in most cases, you want to try to remember to clean up after yourself. So in this case, I can't even do a -v because I'm already down. These are anonymously named volumes. There's no volume found. And the only way really to clean up here is with the command docker volume prune. So this will remove all volumes not used by at least one container. So this is kind of a way to clean up after yourself. But it's better to go ahead and do it up front. So if you are using anonymous volumes, in my opinion, it's best to always clean up when you do your down. So let's look at our volumes one more time here. So we should have one volume here. When you go down now with a -v, that will clean up your volume. And so now we're empty volumes again. The way to be a little bit more explicit about it is to declare your volume instead of having it anonymous. So if we say we want to create a named volume red panda with red panda right here, when we bring it up, instead of having an anonymous volume name, it's going to have a descriptive volume name. So it's prefixed with our directory here, and then sorry about the terminal here. It's got some weird encoding things, _ red panda. The nice thing about naming it instead of using anonymous ones is now let's say we can take down our Docker Compose and we don't want to remove the volume. So we're bringing it down, we're deleting the image, we're deleting the network. When we bring it up again, we're not going to be creating a new anonymous volume. We're going to connect to the one that we've already created before. So this is a way to create a persistent volume across container restarts. And so it is also more descriptive, and it doesn't end up causing anonymous volume spam for your volumes. So I'm going to advocate, especially for examples where it's kind of like the examples where I'm publishing images and having people run one command to bring it up, trying to document the expectation around the volumes and trying to keep them non-anonymous is a good thing to do. And then if we want to delete the volume, when we come down, we can just Docker Compose down and it will delete the named volume for us.
So in the original file where the volume sections were commented out, how was the anonymous volume getting created and associated?
Yep. So we could go ahead and inspect this image. I don't know why my copy paste isn't working here. .8.2. Oops. So the image itself declares a volume. So somewhere in the Docker file for this red panda image, they are doing something like volume, var lib red panda data. And so that means that Docker will always create this volume for you if you don't specify it. And if you don't specify it, it's going to be anonymously named. The other options are to mount it locally, explicitly, or to have a named volume. And so somewhere, again, in the red panda image, there is this Docker directive And you can see that right here when I inspect the image. So if you're not explicit about it, then Docker is going to be anonymous about it, and then potentially create that extra garbage that you'd probably rather not have. So.
Right. What other questions for Devin?
Very awesome. I was thinking that you had to like zip up your containers and pass those around. So this is really nice.
Yeah, I mean, publishing containers is a pretty powerful thing. Docker Hub is the most popular place where images are published, but you've seen we've used the Google Hub container registry.io, ghcr.io. This Red Panda image comes from their own container registry, docker.vectorize.io. But yeah, these are places where you can push images to, and then users can pull them down.
So is it possible to publish volumes as well, or just images?
It's not possible to publish volumes. There's potentially workflows you can do that. You can publish images that instantiate data into volumes, similar to how we've done with the example stuff before. Just to bring this volume point back to the Docker Compose that I had earlier, I am trying to be explicit about all of our volumes here. So the gRPC API image has 2 volumes, data and cache. So I'm being explicit about them. I don't think the web doesn't declare it as a volume, but it will look in that location if it's exposed. So I didn't need to, I'm not actually mounting data into the web image here because it doesn't need it in this case. But it does need a temporary directory mounted. Otherwise, it's going to create an anonymous one. And then, yeah. So
when a user gets Docker running, they set their resource limit. Does that resource limit override these resource limits, or does this one trump it?
What resource limits are you talking about?
When people install Docker, they can set the resource limit. I think the default is like 2 gigs.
I see. Yeah, you're talking about in the Docker desktop. There's ways to do those. My guess is that the Docker desktop is going to be the global limit. And
Okay.
so anything like if you set only 2 CPUs and 2 gigabytes or something like that, my guess is that you're not going to be able to break that limit here. So the Docker desktop is going to be the ultimate maximum limit. In which case, yeah, setting your resource limits too high here, I'm not sure if it just gets capped automatically or if there are issues if you try to use more than that. But I expect that to be the official limit. Yeah, and you don't even need, I don't think, to run with these typically.
No, I removed them.
So, and you should be able to do something like this. I don't know how much of a difference it actually makes. So I've just, created all those same things before without the limits. Let's see if it comes up, I guess. The nice thing when so it is tougher when you're presenting an open-ended workflow like our web console, where you can say, here, user, you can go do whatever you want, but make sure you have enough resources. It is very much a possibility that when we have applications that are tuned for very specific workflows, it should be a lot easier to tune our heap size and our resource limits and stuff like that, because this is, a self-contained application that we know what it's going to do, and we're not presenting an open-ended environment for the user. So in this case, a next step, if I was to, and I can't undo that change to this, would be to, go through and figure out what the resource usage for these different components are, and we could provide much better defaults for this application. It's a good question.
Right, anything else?
I'd like to learn how to figure out the resource limits on those and how you use them and stuff. Because I've come up with that problem a few times. So that might be another good learning thing for us.
You mean how to specify the numbers, or what should the numbers be?
How to see which containers are using which resources for the task that you're running.
There is a broad stroke thing you can look at. So Docker.
Ooh,
there is a
I've never
stats
used
command
that one.
built into Docker. Yep. So you can see code servers also running, and that's how I'm actually displaying this code in the web thing. But I've got a lot of RAM in this machine, 128 gigabytes, so I don't think we're going to run into any limits with this example. But yeah, this is one way to see how much your different containers are using. Let me go ahead and undo all these changes that I've made. And so we'll get back to those resources that I said earlier. Let's see if it actually respects them in our limits here. So if we go back to our stats, let's see. Hey, there we go. So you can see that our Envoy is limited to 256, our proxy is limited to 256, our API is limited to 4 gigabytes, and our web is limited to 256. And right now it's using 17% of the memory, and there's some other statistics over here. Now, if we really wanted to dive deep into setting our heap size appropriately, we need to get more expert advice on exactly what the application's doing, what joins it's doing, how much data is coming in, the data rate, the size of the stuff. But in this case, it's not doing too much, so we're perfectly within its limits. But yeah, Docker stats is a potentially useful tool to look at some of that stuff.
Right, any other questions?
Nope, that was awesome.